All right, everyone. So we are on lesson number 7 here. I know, no intro music today. We're having problems with the app. I know, things we take for granted. All right, so lesson 7 is all about markup and markdown problems. So yes, we've kind of seen this, but we're going to show you kind of a more efficient method and a different way of looking at them, just from an understanding standpoint. So we got Games Galore Superstore buys the latest video game at a wholesale price of $30. The markup rate at Games Galore Superstore is 40%. Use your allowance to purchase the game at the store. How much will you pay, not including tax? So okay, so they want us to write an equation to find the price of the game, all right, at the store. So the big idea here is markup. And this is what happens in the world. There is a store buys something, and what they buy it for, they sell it for more. I mean, how else are they going to make money? So those shoes that you are wearing, all right, if you spent $80 on them, it did not end up costing the store $80 when they bought them. They might have bought it for $40, and now they're selling it for $80. That's how we're making money off of it. Yes, business, it seems a little bit cruel. All right, so what the idea here is you need to end up paying the original price. So you have to pay 100% of the amount. And then added on to it, you're paying the additional 40%. So when we write out our particular equation that we're looking at here, to figure out what the price is, you would actually do 100%, all right, and then you would end up, I'm going to change it to my decimal right now, and then times it by the cost of the game, and then plus, all right, the additional 40%, so again, change it there, times the other amount there. So really what you've got here is 1 4/10 times the cost there. Okay, so again, when we mark it up, we have to pay the original, and then we have to pay what's additional onto it. So when we plug it on in, when we end up solving for it there, the price is going to be 1 4/10 times, and then, the price, which was your 30. So when you go ahead and you multiply there, all right, grab your calculator, punch it on in, you should get 42. So what's the total markup on the game? Well, all right, the total markup. The markup was $12. All right, the cost of the game was 42. The wholesale price was 30. Now, where's that coming from? Well, again, you're paying 42. It cost them 30. It was marked up by $12. So when we're looking at this, you could just find the 40%, okay, which would be 12. Which is your total markup, and then add it on, and that would get you to your 42. So again, different ways of looking at it, but we're going to see that in some of our more kind of, not say elaborate, but longer problems, where there's more things going on, there's definitely ways that we can kind of speed that whole process up. All right, so here we go. So you and your friend were discussing markup rate. He says it's easier way to find it. The total markup is by multiplying the wholesale price by 30 by 40. Do you agree with him here? Okay, so, and this is the key thing is the words. Yes, we should agree with him. And again, it's because of the words that are being used. He's saying the easier way to find the total markup. So just to find the markup, can we multiply it by? Yeah, and that's what we talked about there. So if you do your 30 times your 4/10, again, change it to there, you're going to get 12. So that does find the markup. Now, if we're looking for the actual price, well, then we'd have to add it on, which is why that equation is a little bit nicer. So there we go. We got Black Friday store here. All right. Never been one to participate in that too much. Don't like the idea of waking up. More of a Cyber Monday person myself. All right. So we got a $300 mountain bike. It's discounted by 30%, and then discount additional 10% for shoppers who arrive before 5 a.m. Find the sales price of the bicycle. Okay, so we're going to look at the two ways here. We're going to look at the long way first. The first thing is we can't just add them together. All right, and that's one of the things is they do become separate amounts. So you can find 30% of it. All right, and when you do that, you're going to multiply. And again, you can see I'm not being very formal with my percent equation here. That's okay, no big deal. So that's how much you would get off of the price. So the actual price is $210 because that's when they're taking off the additional 10%. So when we multiply here, all right, we end up with our 21. So now we're going to get $21 off. So altogether, it was 300. We're taking off 90. we're taking off an additional $21, and there's your $189 we're dealing with. Again, not horrible, not bad, but look at it differently here. All right, the original price is $300. If they're discounting it 30%, that means you're paying 70% of it. All right, and then they're going to discount another 10%. That means you're actually paying 90% of it. If you reach for your calculator and you plug that all in at once, the 300 times the 7/10 times the 9/10, go ahead and take a guess. Take a guess. What do you think is going to appear? Yes, the $189. So instead of finding the percent and then subtracting it, finding the percent and then subtracting it there. Oh, and don't forget, you need to get them with your new price. Do that subtraction problem. We can make it just one straight multiplication problem there. So in all, by how much has the bicycle been discounted? Well, if you were using this, you would do the 300 minus the 189. If you were over here, you would just add your 90 and your 21. So you get your $111. When you do your subtraction, guess what you end up getting? Yes, you get your $111. So again, two very good techniques here. Again, which one jumps out at you? All right. So after both discounts were taken, what was the total percent discount? Explain why the total percent discount is not 40%. Okay, so first things first is they're telling you it's not 40%. All right, and this is kind of what we discussed here is the 30% is off the $300. All right, the 10% is off, well, not the 300, all right, but it's off after the 30% is taken. So in this particular case, it was the $210. So the 10% is not being taken of the 300, it's actually being taken of the 210. So what's the actual percent discount? Well, let's think about this. How much did the price change? $111. What was the original price? It was $300. So this is our percent of change. Okay, the percent of change is the same thing as the percent discount. All right, just like the percent markup is, again, percent of change that we're looking at. So if you reach for your calculator and you punch that into your calculator, take a peek as to who's there, and you should have something right around 37%. Yeah. Remember, it is a decimal, and we do need to convert it. So that is a big thing to watch for. All right. A lot of people think that you just add them together, and that's not accurate. All right. I got stories for that, but we'll wait that for another time. All right. So we got Sasha here. All right. She's going out shopping and decided to purchase a set of bracelets for 25% off the regular price. Sasha buys the bracelets today. She'll receive an additional 5% off. Find the sales price of the set of bracelets with both discounts. How much money will she save? So I'm going to go right to it there. So again, if she's going to save 25%, that means she's actually going to pay 75%. And she gets an additional 5%, that means she's actually going to pay the 95% of the price. Right over there, there's your price tag. It is $44. So that's why we're multiplying them all together. So 44 times 7,500 times 9,500, and we're going to get to the actual price that we're dealing with. All right. When we do that, we're going to get $31.35. So the sales price, all right, there's the sales price there. How much is she going to save? Well, she had 44. All right, she's only going to pay this amount. So there's your subtraction problem. Little decimals in there, little decimals, zeros, borrowing, all that good stuff. A little mental math as well is not bad. $12.65 is what she's going to save there when we do the subtraction problem. So there's my two particular answers. Again, much faster, much more efficient than dragging it out. Question 2 here. Golf store purchased a set of golf clubs at a wholesale price of $250. Mr. Edmond learned that the clubs were marked up 200%. Is it possible to have a percent increase greater than 100%? All right. What is the retail price there? Is it great? Absolutely it is there. Absolutely. It just means that it's going to double it there, all right? And this is one of the things that we want to watch for, all right? If something is marked up 100%, all right, you still have to pay the original price and then pay the markup. So it's really a 200% increase, All right. So which means if it's being marked up 200%, well, you still have to pay the original price. So it's really like, yeah, using 300%. All right. So that's one of the things that we want to kind of watch for. We are including that 100% that's there. So let's see what we can do with it. If it is the 250, all right. We're trying to find 300% of 250. So that's your multiplication problem. You hear that word of in there, 300% of, yeah, of does mean to multiply. So that's a little bit of a hint that's in there. Multiply away and you get $750. All right, that's all that it ends up taking. Now, could you go ahead and be like, well, I want to find 200% of this number and then add it on? You certainly can. So I'm going to sneak it right in here. 200 out of the 100. All right. I don't know how much that is, but I know the original amount was 250. All right. If we solve that, all right, and we multiply the 200 times the 250, so that's a 50, 3 zeros, 100x. I know it's getting crammed in there. Divide by 100. Oh my goodness. Take out the zeros there. What you're looking at there is $500. So that means it's being marked up $500. Oh, but wait, you got to pay the original price, which is the 250. Again, all of that versus just this, that's kind of what we're looking at. Let's look at the car here. All right. A car that normally sells for $20,000 on sale for $16,000. What percent of the original price? Now this is kind of nice because they want to know what percent of the original price of the car is the final price. So we can get back into whole part, we can get back into whole there, because remember, discount rate, all right, that's what we're kind of looking for. So we can use the 16,000 and don't know what the percent is, but I'm going to times it by the 20,000. And this is the key thing here. That means when we solve this and we do our division here, divide both sides by 20,000, all right, we're going to end up with 0.8, which is 80%. So the thing here is it's 80% of the original price. Now find the discount rate. Well, if it's 80% other, that means you took off 20%. And this is a key problem here. This is one we want to make sure there's not a lot of work that goes along with it, but the idea of the percent of the original, okay, and then how it connects with the discount rate. That's going to be very important as we're looking at it. So what we want you to do is, this is what we want you to try. We want you to fill this in here. So we're going to write an equation in terms of the selling price of an item that's originally priced S dollars after a markup of 25%. Okay, so we got the selling price, which is the P, all right, and with the original price S dollars after a markup there. Okay, so here's the thing. If it's originally S dollars and it's being marked up by 25%, what are you going to multiply by? Did you? Now wait a second. Where's the one coming from? Because mark up. You've got to pay the original amount. So you have to pay the 100%, and then you've got to pay the additional 25% as well. So when we look at our official equation here, this is what we're going to end up looking like. All right, so that's your price before the markup there. You're going to multiply it there. So here's what you're going to do. We're going to have you fill in the table here. Regarding numbers here, I'm going to have you use a, let's have you use a 10. Let's have you use a 50. We're going to have you use a 100, a 150, and then we're going to have you put in a 300. All right. So I need you to complete the table. I need you to go ahead, come up with your scale, your graph, interpret the points, just like they've got right here. But we can hold off on this. I don't need you to look at exercise 5 right now. Oh, you know what? I take that back. Oh, yeah. Is it proportional? Bringing out our old friends. Is it proportional? So, yeah, finish those problems. We'll talk about them tomorrow in class. Make sure you say something about them in class that we need to talk about them.